My name's Lóránt. Nice to see you all here. Thanks for coming. I'd like to talk to you about the build cache, as many people did already this morning. They actually blew most of the surprise. So, is there anybody who's been here for the task output caching talk last year? I've heard those things. Okay, that's surprising. So it's going to be hopefully a lot of new stuff for you. Okay, let's wait for everybody to settle in. Okay, anyway. So what I'd like to talk to you about is what the build cache is, what it isn't, what support we have already, and like how this is going to continue improving in the foreseeable future, hopefully. So before we dive in, Hans already mentioned the importance of faster builds. It's both important because it improves your productivity, because developers are waiting less, they are getting out of the zone less often, and it's just so much better. And also you need to pay less for your CI infrastructure if you have like significantly faster builds. So that's what we are trying to achieve here. Okay, there's still people coming in. Cool. So we can't really talk about the build cache without talking about incremental build, which is the feature that this whole story is based on. Incremental build has been a part of Gradle, and it was designed with a single developer working by adding small incremental changes, hence the name, and running builds in between. So it tries to reduce the number of tasks that are being executed by that developer. And the way it works is that when Gradle tries to execute a task, instead of like going ahead and do that expensive operation, it first consults its history of tasks, task executions, and tries to figure out if the task's inputs and outputs are the same as they were when they were executed for the last time. And if everything matches up, we can just say that, hey, the task is already up to date, and that's a really cool thing. Because we save a lot of time. And everybody who's been using Gradle is probably familiar with this up-to-date label and this happy, warm feeling that you get when you see it. The way this works is that you, can you read this? I'm sorry, it's a task class. It's supposed to be. I realize that the keywords are not really visible. So anyway. So the way the important stuff is visible. So the way this works is that you, as the author of the task, tell Gradle what your inputs and what your outputs are, and Gradle figures out the rest from then on. It's a really cool feature. It's been improving developer lives for years now. But it has some things that we wanted to improve on, because there are use cases that are not covered by it. We are not working alone as developers. We are working in teams usually, and we do other stuff than just move the Git history forward by small incremental changes. And there's also, so these limitations come from how the incremental build feature was designed to work. There's another factor that comes from how it is implemented, which is, it pains me to say, but sometimes it sort of feels like best effort, and it's no secret to anyone that sometimes you just need to run a clean build to get things back in order. And it sort of damages the trust in Gradle that we have this kind of, it's not flakiness really, it just feels like flakiness because there's so many different reasons why you need to do this. Part of it is that the tasks that you pull in by applying a plugin might not have the proper annotations on their inputs and outputs, and Gradle doesn't know what to do, but it just results in incremental build not doing what you expect. And there are some issues inside Gradle as well. We'll get back to this. So anyway, this is what we want to improve on, and we want to improve on this by the build cache. What is the build cache? So the build cache, everybody says build cache today, but it's it's just some storage that you can put stuff in and get stuff out from, right? It's a feature that you enable by running Gradle with --build cache. It's pretty much like any other cache employed by Gradle, like the dependency cache or the cache for compiled Groovy scripts, your build scripts. It's just a storage. But what you get if you enable build cache right now is task output caching. So we use the build cache to put stuff in there. We put the outputs of tasks in the build cache. And the build cache can be implemented in different ways. One of these implementations is the local cache. You get, as you've seen in the keynote, it gets enabled automatically when you run any build with --build cache. It means that Gradle is going to put task outputs into a directory on your computer and load them from there. And this is really cool when you are not moving the history forward step by step, but you are moving sideways in history by switching branches. So suppose you're on master, right, and you've built you executed whatever build you're interested in, and you need to switch to some branch, do some different builds there. And when you switch, Gradle is only going to see that there's a bunch of changes being made to the source code. Gradle does not understand that you might have branches or whatever. It just sees that the inputs of those tasks have changed, so they need to be re-executed, right? But when you switch back to master again and continue your work there, the local cache is going to kick in and will say that, hey, we've seen these inputs. They've changed since the last execution, but we've seen these inputs and we know what outputs correspond to those inputs. So it just pulls those in, and that speeds up working on branches quite a bit. And also when you use tools that make use of the history in your version control system like Git bisect, it's also a great help. But we can go further, and actually this is where the real performance improvements are, when you actually start sharing cached outputs in your team. And we ship an HTTP connector, and the Gradle Enterprise installations come with a pre-installed build cache, so it gets you going instantly. And what it gives you is twofold. You can make use of the shared cache on CI, so just use it among your CI agents, and it allows you to share task outputs between these CI agents. And this is really important because usually you have lots of CI agents and they are building different change sets in parallel, so sharing outputs between those guys is very important. And if you have like a really complex workflow setup where, for example, you're running a bunch of integration tests in parallel, each of those jobs is probably doing a lot of Java compilation and other stuff that is exactly the same as some other agents are doing at the same time. So a shared build cache will save you a huge amount of time there by just distributing that pre-built results between these agents. And sometimes we go to a lot of trouble to manually implement something like this, packaging things into zip files, sharing the whole workspace in some way. You don't need this with a shared build cache because it just works automatically, and it's pretty cool. And for developers, it's obvious advantage is that if I make a change, all of my teammates don't need to build that change locally when they pull from version control, provided that change is sufficiently independent of whatever they're working on. And this can, depending on your team size, this can be a really, really big boost. As we've seen with the Tableau results, yeah, it was really cool to see that. So that's exactly the purpose we're going after with the shared build cache. This calls for a short discussion of like how you're sharing stuff in the shared build cache. What we recommend to do, is that visible? Yeah. What we recommend to do is to only push from CI, because CI is a much more controlled environment than developers' machines. That means that you know what is installed there, what versions of each tool and whatever, what operating system version, etc., which might have like really small influences on the output. And the other thing is that right now, developers can even accidentally make changes to the output of tasks while the tasks are running just by continuing to work in their IDEs, and Gradle does not support any kind of strategies right now to avoid that messing with the cached output. So it's safest to push from only CI agents, but it's possible to enable it from any developer machine and then share in between each other. And there's also, if you share from all developer machines, you need really fast upload connections from every developer for this to make sense, and it's probably going to use a lot of data on the cache server. So in any case, if you start using the build cache, we would recommend you start with CI pushing and yeah, see how far it gets you. So how far does it get you? It's hard to put a single number to this. Of course, with any caching measurement is hard because there's so many factors that come into play that decide what you will actually get, and it's only meaningful to measure any kind of impact during a certain period of time, because the impact depends on what kind of changes you're making. Are you making changes at the root of your dependency tree and it influences everybody else, or you're making changes to documentation which influences nobody, well, hopefully somebody, but not your tasks at least. And it depends on how your code is structured, how your build is structured, so your mileage may vary. With that, we obviously had to measure our own improvement, own impact, the impact on developing Gradle itself. And we are a very bad example. Most of our developers work from remote locations in the top of mountains and little countryside villages, and we have pretty bad internet connections. And our code is not the best in that we have like this huge core module where a lot of the work is happening. But even with these things, we could measure a 8% roughly improvement over not using the cache. But don't take that as your base number. Take the Tableau results as a basis, because those will be much more close to an office kind of setting where people have fast connections to the cache server. Something which is more relevant is our results with our CI infrastructure. So this is the result of our most basic build. This is the first thing that runs on any commit, which is a sanity check thing. It runs some code quality, does compilation, doesn't run any kind of elaborate tests. And with 42 builds that we measured here, we saved 25%, which amounts to 3 hours of build time, which is not a huge deal. But if you look at the more elaborate tests, which involve like integration tests executed on Linux and Windows, there's a big impact there. And we saved a significant amount of build time, even on a pretty small sample. So, yeah. And yeah, another reminder, this is the Gradle Enterprise build cache statistics page with a pretty high number of hit rates, 87%, but of course that's typical to our builds. It's not going to be typical to your build. What you need to watch out for is how this changes, how build times are changing, and Gradle Enterprise is a really awesome tool to measure those kind of changes and get those statistics from. So this is all very cool, but as I mentioned at the beginning, there are some challenges because task output caching relies on the same task metadata that we already know can be problematic, and the effects are much more serious because you can't just do clean as you could fix any incremental build problem by running clean. You can't fix it when your task outputs are cached in a shared cache, for example. They're just going to keep coming back. So the good news is we're committed to fix this for good, which also means that we want to fix incremental build in the sense that it's not best effort. It should work all the time. It should do the right thing all the time. But it's a pretty long journey because there's many different reasons that we need to fix. For the third-party plugins, tasks introduced by third-party plugins and custom tasks, we are going to produce a lot more warnings to tell you what the problems are. Build scans already produce a lot of information about that, and we are going to add even more safety rails. We want to enforce good practices like tasks having exclusive access to their outputs. So no two tasks should write to the same directory, basically, because then it's really hard to figure out like which task produced which output, what to cache. It's problematic for parallel execution because like what if they override things, then your output is dependent on the order that these things finish, and let's not go there. So basically we are disabling advanced features like task output caching and parallel execution when we see something fishy like that. And there's some plans to do more isolated executions. So instead of like letting your task just roam around in the file system and do whatever they want, somehow narrow down the possibilities and then only feed inputs that are actually declared to the task and then spoon out the outputs produced that are actually declared. So as Hans mentioned, the cache is a really good forcing function to move builds to be more stable, more reliable, because that's how you get all these benefits. So this means that there's some work to do in most builds, and it also means that there's some work for us to do on Gradle. So we already finished a few things that are going to make Gradle much better to use as a developer. State of file cleanup, so there are some cases where Gradle was leaving some files around when it just lost all the information about like what should be in the output directories. We're much better with that, and we are improving there as well. We're tracking Java versions much more closely. So previously, if you recompiled or rebuilt your project with a different Java version, not every your Java code might not have been recompiled in some cases, or your tests might not have been re-executed. This does not happen so often, and it's like if I change the JDK used, it's sort of like I can do a clean build. It's like fine, but if you have like two computers sharing cached results using different Java versions, you don't want them to mix that up because that's just going to be horrible, right? And yeah, we are cleaning up. We're doing these best practices on our own side. So when I was saying that tasks should have exclusive access to their outputs, we were not observing that with, for example, the JVM compilation tasks. So if you had Java, Groovy, Scala compilation together in the same project, we would put all the output files, all the class files compiled into the same directory, and that's a small breaking change in 4.0. It's not a breaking change. In some cases, it can be a breaking change. Sorry about that, but this is like the steps that we need to take to get to a more stable, more reliable future. We're trying also to improve documentation. As Hans was introducing the guides, we have a pretty long guide for anyone who wants to introduce the build cache to their own existing builds. It discusses a number of issues that you need to watch out for. My excellent colleagues Stefan and Sterling are going to have a talk tomorrow at 1 p.m. in this room about some of those topics, like how the practical side of all this works. And we updated the tasks chapter of the user guide with a lot more information about how to declare inputs and outputs and all the nice stuff that we have going for the build cache. Sharing results between computers introduces a complete new set of problems because, like, the operating system is actually an input which we never really observed, right? You were not replacing the operating system under your build between two builds. But if you are, again, sharing results between computers, a Linux machine and a Windows machine needs to work together, and we need to figure out if the default file encoding is influencing your build or not, if what tool versions are installed that you are just invoking. So all of those things need to be observed. We also have a completely new concept. We call it relocatability or path sensitivity. It's an interchangeable term. Basically, the idea is that if we're working in a team, everybody is probably checking out the source code in their own home directory or in a directory of their choice. And Gradle does not know automatically if it's okay to share those results with people who have checked out things in another location. You need to tell Gradle what the path sensitivity is of your input. So for example, here I have some kind of task which receives a directory as an input, and here I'm saying that the task only cares about the relative location of those files compared to that source directory, but we don't care about where the source directory is. If it's in your project, outside of your project, if I move it around, that's still going to keep the task up to date and allows people with different paths to this source directory to share results. But if I move files inside a directory, that's going to result in a different set of inputs as far as Gradle is concerned. Another thing, so this is not as easy as it looks like sometimes. I don't know if I have the time to go into a lot of detail here, but basically this is a task that concatenates some files that it calls source files. It's a file collection, right? And there's a problem here. I don't know how to invoke the. Never mind. So the problem is that Gradle by default does not observe, by nature doesn't observe the order of those source files, right? And that's why we are actually sorting the source files before concatenating them, but that sorting depends on the absolute path. So if you have different absolute paths on different computers, it could result in a different order of files being concatenated, so your output is actually dependent on that Anyway, so this is not a completely correct task. It can produce surprising results, and it's surprising. It's such a simple thing, right? And so it's hard. We are trying to figure out how to give some warnings about cases like this too. So for this reason, we only turn on caching for tasks by default that are actually annotated with this cacheable task annotation. It means that this task is okay to be cached in the sense that it makes sense to cache it. Like if you have a copy task, it does not make any sense to cache the results of a copy task because it's just moving files locally, unless you're doing some extensive processing in the copy task. And it also means that somebody put that cacheable task annotation there, and if you do blame on that file, you can see that who was the guy or girl who said that, hey, this task is okay to be cached in the sense that we have all the inputs and outputs properly annotated and whatever. We also don't, it's a tough topic. We don't really officially support doing this yourself yet. So we want to add a lot more safety rails and warnings and validations before we are comfortable saying that this is a feature supported globally and you can go ahead and do it to your own tasks. But it's also possible, so nobody can stop you from doing this. But we have support built into Gradle 4.0 for Java projects, so Java compilation, test execution, all the code quality tasks that are shipped with Gradle are caching aware, and Javadoc is also supported. As Hans mentioned, again, support for caching in Android is coming in the Android plugin 3.0, and we are going to ship Scala Groovy and native tool chains with caching support in Gradle soon as well. Okay, so be sure to check out the build cache guide. There's been a lot of work going on into that guide, and it's a really excellent source for information about introducing the build cache. And yeah, make sure you check out the Gradle Enterprise cache, which is really cool. You just set it up and it just works. There's the link to the slides, and there's a Slack channel for the talk. People told me I should set one up, but I'm not exactly sure what the purpose is. But let's continue discussing things all about the build cache there. There's going to be the other talk from Stefan and Sterling tomorrow here, 1 p.m. Hopefully there's not going to be a delay like today. Probably you guys should use the same channel, I guess, or something. And there's another really cool talk from Cedric, who was part of the performance team. So there's a lot of work going on, as you might imagine, on improving Gradle performance. And he's going to discuss how to improve incremental builds. But if you improve incremental builds, make them more reliable, make the task definitions better, that's going to improve your build cache performance as well. So that's going to be a really awesome talk to go to. Well, I guess that's it. Thanks.